Hi, everybody. You're hopping back in, maybe. You've stumbled your way through that last problem of our lesson, and you now have a solution to it, or you've been playing with this thing for a day or two, and we're stumped. Okay, so now we're going to walk our way through this one. I take a look. The instruction was to go through and to solve this. I look and see where my variable is. It's up in the exponent. I got to get it out. I need a power equal to power base the same. What is screaming at me right now is that minus in between. So I can see that I have one term and two terms. Now, one of the issues might be that I want to now common factor this to turn it into one term to solve that problem. But as I look at my powers, they're not powers of the same base. Well, if we've gone through that entire decision-making process or strategy, then I think our key would be, can we make those powers of the same base? And pretty quickly, we see that we can write both of them as powers base 2. So I'm going to leave that 5 out in front, and I can change my 4 to the exponent x to be 2 to the exponent 2x. And now I get to a point where I love that line because both of my powers contain a 2 to the exponent 2x. So what I can do now is I can common factor out my 2 to the 2x. And I can deal with that, and I'm just going to very quickly factor that out. That would leave me with 5 from the first and the second. Look inside your brackets. It's nice. It's all numbers. That means it's a constant. That means we can calculate stuff. However, I maybe don't want to work with that because now I would have to take 5 minus 7/8. I've got to get a common denominator. I've got to work with fractions. It's just a pain. So all of that could have been avoided if instead of just factoring out my 2 to the 2x, I factored out the smallest exponent I have. There's my 2 to the exponent 2x minus 3. That will solve that problem. Well, that means that I'm going to have to multiply by my 5 and a 2 to the exponent 3. To get back to my next term, I just have to multiply that by a negative 7. And you take a look at what you have inside the brackets. It's all a constant. And what's nice is my exponent's positive, so I'm going to get to deal with whole numbers. Okay, it should almost be automatic to finish this thing off. Now I can go ahead and calculate what I have on the inside. 2 cubed is 8. Multiply that by 5 is a 40. Subtract a 7, 33. I'm going to now take that 528 and divide it by 33, and I love that that's going to give me 16. But I can be really efficient if I automatically change that 16 into 2 to the 4th. Now that I have a power equal to a power base the same, I know therefore my one exponent has to equal my other exponent, and I am good to solve. Okay, so I hope that we can see that, yeah, G was a little bit uglier, had a little more to it. However, I think that should have been something that we could have considered. My guess would be is that we maybe either came to that after stumbling through a little bit, or now that you see it, you go like, oh my gosh, how did I not try to just change the 4 into a power base 2? Okay, hopefully that helps you out with your doozy, and hopefully all your practice is going well. Good work.